So we're in Unit 8, Chemical Reactions, and the last thing we're looking at is ionic equations. This is really the last piece of this unit, and this has to do with reactions in aqueous solutions, which means we're talking about double replacement. So I'm going to give you one example through here, and then we're going to go back to a few places in the notes and practice this. So first thing, there are a couple types of ionic equations. There's the complete ionic equation, which shows everything in the reaction. And then there's a net ionic equation, which is a little bit shorter and probably more useful. But to get there, we have to talk about the complete first. So we have a double replacement reaction between aluminum sulfate, Al2SO43, and sodium hydroxide. Now, before I get into these, I like to find the charges for everything, just so I know what I'm working with. So that way, when I start predicting my products, I already know what the charges are, and I'm not tempted to change chemical formulas to make it fit what I want. I'm able to identify what they are in the real world. So some charges. So I know that aluminum has a 3+ charge. It's in group 13 on the periodic table. Now you may or may not know the charge of sulfate, SO4. It's at the end of the ionic compounds unit in a table, but some situations where it's not really that helpful to flip all the way back, because we could figure this out here and now without actually knowing its charge. So SO4 is a polyatomic ion, and here's how I'm going to find its charge. So to get to a chemical formula, we would switch the charges. Here, what I'm going to do is basically go in reverse. So there were 3 of these, and aluminum has a 3+ charge, which means that since there were 2 of these, sulfate has a charge of -2. And that's how you work backwards to find the charges. My other compound, so I have sodium, which is an alkali metal, and I have hydroxide, which is a polyatomic ion. But look, all of the subscripts are 1, and the charge of sodium is 1+, and so that means the hydroxide is -1. There we go. Here's what's going to happen. The aluminum is going to react with this hydroxide, and the sodium is going to react with this sulfate. And so we're going to come up with 2 products here. So one of them, between aluminum and hydroxide, and I'm going to switch the charges. AlOH3. And I don't know what its state is yet, so I'm going to put parentheses and come back to it. And my second product is between sodium and sulfate. So there's going to be 1 sulfate and there's going to be 2 sodiums. we're going to have to check that one too. So we flip to page 11. I've already identified these. So sulfates, like your sodium sulfate, generally going to be soluble. Let's check the exceptions just in case. And yeah, we're good. So this one is going to be aqueous, our sulfate, aqueous. And our hydroxide, so compound contains hydroxides, insoluble, and we just have to double check. Is aluminum one of the exceptions? And no, it's not. So it's going to be solid. So while we're at it, we're going to go ahead and balance this equation. So let's take a look here. We have, let's write all of these out. I'm going to do it down here. You're going to end up writing here, so you might want to be careful where you write it. I'm going to treat SO4s like they're one piece. Same thing with the hydroxides. 2, 3, 1, 1, 1, 3, 2, 1. Okay. So we're going to go through this in what I call the trial and error method. So we're just going to start changing numbers and following where they go until we think it's balanced. And we're going to check it. So what I would do here is change the aluminum one to a 2. And that means I now have 6 hydroxides. And I'm going to go over here. I have 6 hydroxides. I only have 1 here. So I'm going to make this a 6. And that changes the sodium to a 6. So then I'm looking at sodiums over here. I want this to be 6, which means I'm putting in a 3. Oh, very good, 3. And that changes the sulfates. And it looks like we're balanced. So you just kind of go until you think you're balanced. And let me erase this and then we'll double check. 2 aluminums, 2 aluminums, 3 sulfates. Wow, this pen. This is not going to be a pointer now. So we have 2 aluminums and 2 aluminums, 3 sulfates and 3 sulfates in the products, 6 sodiums in the reactants, 6 sodiums in the products, 6 hydroxides, 6 hydroxides. And so this one is balanced. So now we're going to write the complete ionic equation. And this takes up a lot of space. So I'm going to start as far to the left of my paper as I can. I know a lot of you like to start about here. But I'm going to start it right over here, and I'm probably still going to run out of space. I am going to look at every ion individually. So the first thing that comes up, this is an aqueous compound, means it dissociates. aluminum aqueous. I actually need to include its charge here. Beyond that, I need it balanced. And so there's a 2. This is its subscript. This is the only time that a subscript is really going to change. So you dissolve this in water, and we end up with 2 of the ions, which is this. We end up with 2 of these aluminum ions. Plus, the next thing we have is this sulfate, SO4 2-, which is also aqueous. And if you take a look here, we have 3 of these. And in the compound, it's this parentheses, SO4 3. But once it dissociates, that's just 3 of these sulfate ions floating around. We do the same thing moving on. We have 6 sodiums. So here's my Na+, and the subscript is 1, but there are 6 in the coefficient. So there's 6. Same thing with the hydroxide, 6 OH- aqueous. Now we're at aluminum hydroxide. Aluminum hydroxide is a solid. It has not dissociated. It is not aqueous. We are not going to divide this up. So here we're going to write 2 aluminum hydroxides solid. See how different? And then we go on. Plus, look at this. We have 3 sodium sulfates. 3 sodiums times 2, that's 6 sodiums. And check it out. There were 6 over here, so that's a good sign. Plus 3 sulfates, aqueous. And over here we had 3 sulfates. And so everything here is still balanced, it's just written differently. That's the complete ionic equation. And it took up the entire width of the page. And I'm not really a huge fan of complete ionic equations because there's a better way to write it. And that would be the net ionic equation. And the net ionic equation only shows the ions that are involved in producing your gas, your precipitate, or your water. The ions that are not involved are called spectator ions. They are present, but they're not actually involved. That's why they're spectators. They are not included in the net ionic equation. So let me identify for us some spectator ions. I'm going to use this green color. So spectator ions, I'm going to box them off in green so that we can see them. Spectator ions are present, but they don't do anything. These would include things like my 3 sulfates, which are aqueous in the beginning and aqueous in the end. They're not really doing anything. They're just there. My other spectator ion, sodium, aqueous. They're present, but they're not really doing anything. They're not actively making one of these 3 types of products. And so we're going to rewrite our complete ionic equation, but we're going to write it as a net ionic equation, meaning what actually happened. And here's what actually happened. We had 2 aluminum ions. reacting with 6 hydroxides, aqueous, and it produced 2 aluminum hydroxides, which were solid. This is our net ionic equation. And as you can see, this is much faster. So I'm going to go back all the way to page 8. And we had some double replacement reactions here. So I'm going to write the complete ionic equation. And I'm going to do it in a different color here. So I'm going to write the complete ionic equation in red. Now here's what happened. So we had this solid and we added it to this aqueous. And remember I said that they both became part of the aqueous compound. So I'm going to actually edit this. It becomes aqueous when it's mixed up. And so here's what we're looking at. Iron 2 plus, aqueous plus, sulfur 2 minus, aqueous plus 2 hydrogens plus 2 chlorides yields. This is my gas. It's no longer dissociated. It's going to be producing bubbles out of this solution. It's going to stay as H2S gas. And then here we have our iron. Remember, it's charged. It's still 2 plus. Charges don't change between here and here. Plus, we're going to have Cl minus, and there are 2 of them. And that's aqueous. This is the complete ionic equation. And we could identify spectator ions. That's 2 chlorines, 2 irons, and whatever's left is our net ionic equation, which I'll do in red. Sulfur ions plus 2 hydrogen ions yields H2S gas. Looking at this next one, if I write out the complete ionic equation, I'm going to have 2 lithium ions plus 1 sulfate. And remember, the charges need to be here. Plus, here's barium. There's going to be 2 chlorine ions. So over here, we're going to have 2 lithium ions plus 2 chloride ions. Plus, here's the solid that we made, barium sulfate, which is a solid. So my spectators, lithium, chloride, and whatever's left over would tell me my net equation. And the net equation is much shorter and more convenient. So back to page 10 at the very top, I'm going to look at these two chemical equations, but I'm not going to write the complete equation. I'm just going to go straight to the net, because I think it's important for us to know how to go straight from here to the net equation without having to write across the entire page. So here's what happened. In this reaction, barium chloride plus magnesium sulfate, we produced a solid barium sulfate. All I want to know is what made this. There were two things. There was a barium 2+ ion, which was aqueous, and there was an SO4 2- ion, which was aqueous. And so that's really the short way to do it when you want to find the net equation. The net equation is basically what really happened. This is the short version of the story. Finally, in this last one, this KCl plus sodium nitrate. So what really happened here was we had these two aqueous compounds and there was no reaction. What really happened was we just had KCl plus NaNO3 aqueous. These were the products. Now, if you were asked for the net equation, there is no net equation. This is really your final answer, whether you're talking about the actual balanced equation or the net equation. But you could write the complete ionic equation if it were requested. I mean, it would be a lot of work, a lot of writing, and you wouldn't get much out of it. But it could be done, and really it would look like this. I'll just write it quickly so you can see it. And you're ending up with really all the same stuff. It's just likely to end up in a different order. And this is the complete, and if you were to circle the spectators, you would circle everything. And remember, the net ionic equation is what you didn't circle. And so if you circled everything, then there is no net equation. And take a look at this. Potassium, potassium, chloride, chloride, sodium, sodium, nitrate, nitrate. And there's no net equation here. That's it for this unit. Make sure you study. If you have questions, please ask. Please send me an email. please come see me in my room. I'll see you soon.